Hi guys, just a quick lesson on reviewing right angle triangles. So the first thing that we're going to remember is what a 90-degree angle is, referred to as a right angle. Okay, and we also need to know that if the side opposite the right angle is called a hypotenuse. Okay, so we can label that on any diagram. If we have a right angle triangle, we can label the side opposite the right angle a hypotenuse. So the first thing we met when we were looking at right angle triangles was Pythagoras' theorem, and that just said that a squared plus b squared was equal to the c squared, and c squared being the square of the long side, and the long side was the hypotenuse. So we need to remember that a squared plus b squared is equal to c squared. First couple of examples that we have here, consider the right angle triangle. So I'm trying to find c in this right angle triangle, so this is my hypotenuse. And that means that I'm going to be finding the long side, so I have to add the squares of the shorter sides. Okay, so to do that, we're going to use c squared is equal to 3 squared plus 4 squared. 3 squared is 9, 4 squared is 16, total 25. And to work out the actual value for c, we have to square root 25, which gives us 5. On my second example, though, I've got my hypotenuse is already given to me, so I'm trying to find my b, which is my short side, so that means that I'm going to have to subtract. Okay, so subtract for this one. For this one, I have to add them after I squared them. So the first thing that we're going to look at is that b squared is going to be equal to c squared minus a squared. So that's 169 minus 144, which is again 25. So b is equal to the square root of 25. Okay. Just revision. So using Pythagoras' theorem, we can work out the following questions for each side. For each of the following triangles, calculate the length of the missing side. So in this situation here, we're trying to find the hypotenuse. In this one here, it's a short side because we're given the hypotenuse. Again, we're trying to find the hypotenuse. Given the hypotenuse, and finding the hypotenuse. So just remember whether you're adding or subtracting, and we've got quick notes up here in the corner. So the longest side you add them, the short side you subtract them. Okay, so when you work out the answers, give it a go and check your answers. The first answer is 6.7, 9.8, 23.6, 5 millimeters. Watch out for your units, make sure they're accurate. 1.0 centimeters. It's asked you to round to one decimal place where needed, so make sure you got question 5 right. And 65 centimeters in the last one. A couple of more examples, but they're a little bit harder. Calculate the length of the diagonal in this square. So again, you have to recognise that because it's a square, the side lengths are the same. So we can straight away see that this is also going to be 66 centimetres. I have my right angle, so I'm trying to find my hypotenuse, and I can work it out from there. In this one, again, you need to remember to draw your diagram and fill in the information. So if a right angle triangle is a short length, 14 and 8, so we don't know the hypotenuse again. Okay, that's the one we're trying to find. 14 and 8, it doesn't matter which one is which. I'm trying to see who's the longest, but it's hard to see. Actually, I think I could have done them the other way around. So I'll say this one is 8 and this one is 14. Okay, so draw your own diagrams, don't be afraid to do that. The answer for the first one is 8.5 centimetres. The answer to the second one is 16.1 centimetres. Okay, looking at my next diagram, I'm talking about an isosceles triangle, so I know the two sides are equal, and I'm trying to work out the height. Okay, so I'm trying to work out my height, this line here, so I'm going to use just one triangle, one right angle triangle. Let's take this one for example. I can see that there's a right angle here. If my base entirely is 8 centimetres, then I know that half of it, which is what's represented in this triangle, is going to be 4 centimetres. So I can work that out, and now I have my right angle triangle. Hypotenuse is 12. One of my short sides is 4, and I'm trying to find the height of the triangle. Probably shouldn't have called that h because it might confuse me. This is my hypotenuse, so we can write HYP on that one. So this one is HYP, and we're trying to find the height, and you could call it h if you want, and work out an answer and check it. So you get 11.3 centimetres. Okay. And the last one, same idea, but this time you're trying to find the base. So locate the triangle that you're going to use. Maybe you'll use this one. fill in that this is a right angle, and we're trying to find this distance here. But remember, when you find that distance, you have to multiply it by 2. These are the things you need to be thinking about. And your answer is 12 centimetres. Okay, let me know if you had any questions with them. And again, we've got notes on the sides, longest side, shorter side, and the corners. Some real life problems. Make sure and always draw a diagram when it's just a worded question. A boat travels 45 miles east and 60 miles north. So again, north is a vertical line and east is perpendicular to it as a horizontal line. So we can straight away draw a triangle. So east 45, that should be shorter than the 60, so I'll just fix that in a second. And north 60. So actually I've drawn the triangle underneath, so I can just label it. So that's a better idea. So north is going to be 60 and east was 45 degrees. Again, my 45 miles looks a bit longer. It doesn't matter. You only need to know that it's a right angle triangle. So we're trying to find our hypotenuse. Okay, swimming pool is 25 by 12. If someone swam from one corner of the pool to the other, how far would they have swam? So a swimming pool is normally a rectangular shape, and it's 25 by 12. You're trying to find the diagonal, so you're trying to find this distance here, which is also going to be a hypotenuse because it's opposite the right angle. So we know that this is 12, this is 25, etc. A ladder leaning against a wall. So you've got a ladder that looks like this, leaning against a wall. My wall is going to be obviously perpendicular to the ground, like so. The bottom of the ladder is 1.5 away from the bottom, so between this distance and this distance it's going to be 1.5 meters. And we know that it's a 4 meter length ladder. Okay, so I'm trying to find this distance here, the height from here to here, so that's my x. Up the wall, how high up the wall it reaches. So there's my right angle. I know that the ground is perpendicular to the wall, and I can solve it from there. A rope of length 10 meters stretched from the top of the pole 3 meters until it reaches the ground. So we've got a pole, top of the pole is 3 meters, and the length of the rope goes the whole way 10 meters. And I want to find how far the end of the rope is from the base of the pole. So this is my right angle. I'm given the hypotenuse this time. I'm trying to find the distance from the end of the rope to the base of the pole. Work it out. Your diagram is key. The next thing that we're going to look at is trigonometric ratios, sine, cos and tan. Again, it's just revision. Take a right angle triangle and label the sides. Okay, the first thing that you need to do is locate your angle that you're talking about. We can refer to it as A or sometimes theta, which is the Greek letter for Q. And from there you can label your sides. So the side directly opposite the angle is the opposite. The side obviously opposite the right angle is the hypotenuse, and then the adjacent is the remaining side. And from there we can come up with ratios. Sine, cos and tan are my ratios. And I'm going to write them using the sides that they are applicable to. So just bear with me a second. So the sine of A is going to be the opposite over hypotenuse. The cos of A is equal to the adjacent over hypotenuse, and the tan of A is equal to the opposite over adjacent. Okay, so we use SOHCAHTOA to remind us of these ratios. Okay, so some people have little rhymes as well. 2 old angels skipped over heaven carrying a harp. It doesn't really matter what order the sine, cos and tan are in, as long as your letters SOH, CAH and TOA are all in order. Okay. So let's look at some examples. The first thing that we always do is I always label my sides that I'm given. So in this one here, we're given the opposite. So O for opposite, and we're given the hypotenuse. So I'm going to write out my SOHCAHTOA. So SOHCAHTOA, and I'm going to tick the ones that I have. So I have my opposite, and I have my, sorry guys. Being a bit particular. So I have my opposite and I have my hypotenuse. So if I have my opposite and hypotenuse, that means I'm going to use sine. And I can say that the sine of 35 is equal to the opposite over hypotenuse, which is equal to b over h. So I don't need these ones. And b then, if I rearrange my equation, I end up with b is equal to 8 times sine 35, and I work my answer out to be 4.6, correct to 1 decimal place. Okay, the next one. Again, label my sides. So this one here is my opposite. I don't need my opposite. So I do have my h, my hypotenuse, and then my remaining one is adjacent. So again, if I was to write out my SOHCAHTOA, SOHCAHTOA, and tick the ones that I have my h and I have my adjacent. So if I have my h and my adjacent, I'm going to be using cos, okay? And the question is underneath, so I'll just rub that out. So the cos of 30 is my angle, is equal to the adjacent over hypotenuse, which is equal to b over 4. And then I can rearrange it by bringing my 4 over and timesing it by cos 30 to work out my b. B is equal to 4 times cos 30, which is equal to 2 root 3. Okay, so for this one it's a little bit different because we're actually trying to find our angle, but you start off the same. This here is my opposite and this here is my hypotenuse. Okay, I know that I'm going to be using sine, because SOH, when I take the ones that I have. And then I know that sine A is going to be equal to opposite over hypotenuse, and my opposite over my hypotenuse is 2 over 7. So now I can rewrite A as the inverse of sine 2 over 7, which gives me 16.6. So when you're trying to find the angle, you use the inverse function. So to find angle, use inverse. And the inverse function is always, when you press the second function key on your calculator, it gives you the sign -1. Okay. So for the one below then, it's the same idea. I've to label my sides, so I have my opposite, which is O, and my H, so again I'm using sine. So the sine of A is equal to opposite over hypotenuse, which is 3 over 6. The sine of A is 1/2, and then to work out my A, I have to do the inverse function of sine of 1/2, which gives me 30. Okay. A couple of other things that we need to remember for right angle triangles is what the angle of elevation is. So it's formed by a horizontal line and the line of sight. So when you're looking up, okay, the angle of depression is the horizontal line and the line of sight below, so you're looking down. Okay, so this eye is looking down, this eye is looking up. And remember that they are related because the two horizontal lines that we're talking about, this line and this line, have to be parallel to each other, so we end up with alternate angles, which means they're equal, the angle of depression and angle of elevation. Okay. So for this example, if a tree casts a shadow of 18 feet long when the sun is at an elevation of 35 degrees, how tall is the tree to the nearest foot? So the picture might not always be given to you, but here it is. So we're trying to find the height of the tree. We're trying to find x. We know that the tree casts a shadow of 18, so that's going to be this distance here. And it's at an angle of elevation from 35 degrees, so I'm looking up. Okay. And then I know what sides I have. So this is my opposite and this is my adjacent. So again, I'm going to be using O and A, so I'm going to be using tan. So don't be afraid to write out SOHCAHTOA every single time and label what you have. Tick what you have. So I have my opposite and I have my adjacent. So I'm going to be using tan. Okay, so the tan of 35 is equal to x over 18. And then when I bring my 18 over, I multiply it by tan 35, so x is equal to 18 times tan 35, so x is equal to 13 feet to the nearest foot. Okay. Next example, a plane at an altitude of 3,000 feet observes the airport at an angle of 27 degrees. So the angle of depression, so the plane is looking down, is at 27 degrees. That's at 27 degrees. And it's at a horizontal distance, the plane and the airport, that's what we're trying to find. Okay, so the altitude of the plane is 3,000, so this is what I've given here. And again, my 27, because that's 27, I can see that that's 27, or I could use, if I wanted to, this triangle. Okay, it's the same triangle as this one here. Okay, so again, what are we given? We're given our opposite when we're using this triangle, and we're trying to find the adjacent. Okay, so write out your SOHCAHTOA. You tick what you have, so you've got your opposite, opposite, and adjacent, so you're going to be using tan. And from there we can say that the tan of 27 degrees is equal to the 3000 over x. My x is on the bottom this time, so there's a little bit more moving around. So if I bring my x up, I'll have x times tan 27 is equal to 3000. Trying to isolate my x, so I have to bring that down, divides, because it was times here, so when I bring it under it becomes times. So I get x, sorry, when I bring it over it becomes divide, it was times here. So I get x is equal to 3000 divided by tan 27, so x is actually equal to 5,300 feet. So it's 5,888 feet away from the airport. Sorry. Not long now, sorry guys. Compass bearings, if the angle is in first or second quadrant, so if it's in this quadrant or this quadrant, then we're going to measure from north, that's my starting point, to east or west. So from A, I'm going to be measuring from north to east. For B, I would be measuring from north to west, and it's that distance in between. So N to A, I'm going to be looking at N30 east, okay? For B, I'm going from north to west, so my N and my W are my letters, and then the distance from north to B is going to be 60 degrees, so it's N60 west. If it's in this third or fourth quadrant, so this one or this one, then we measure from south and we go east or west. So C is starting from south going towards east, so it's south 70 east, okay? And my D here is going from south to west, so it's south 80 west. Just one quick thing, if I wanted to measure this angle in here, I would still say south 70 east, okay, because I'm going from south to east always. Alright, so if I was given this maybe instead, if I was given this was 20 degrees, I'd still say that my angle is south 70 east. Okay, and the last thing that we're going to look at is the true bearing. So find the bearing find the bearing of B from A. So A is my starting point, so I mark the north line on A. Okay, if there isn't one, draw it in. A is my starting point, I'm going from A. That's really, really important. Draw the line connecting to B. So from A to B, and measure the angle clockwise, always clockwise. So the steps are start at north, facing north, measure clockwise, and you must have 3 digits. Okay, so if it was like 43 degrees, you would have to just put in that there's an extra 0 in the front. Sorry, jumping around the page. And that's that one. Okay, so now we can look at this. So draw a line connecting A to B, measure the angle clockwise from north to B, from the north line to B. So I put my protractor on and I count them down: 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 135. So I can say that my bearing of B from A is 135. Okay. The last example is just a little bit more complex because it's the whole way around, because remember you have to go clockwise, okay? So this is from find the bearing of A from B. So we're starting at B, so because I'm starting at B, that's where I draw my north line. And then I want to connect my line from B to A, so that's to show me my actual angle, okay? Measure the angle clockwise from north line to A, so I'm talking about all this I know is 180 degrees already, so I now need to work out how much more I've gone. So I put my protractor on it, and I can see from here all the way up to the A, so 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 135. I have to add on that 135 now to the 180 to work out my total distance from B to A, and I get 315. Okay, so 135 was the angle that I need to add on to the 180. Okay, and that's it, we're done. Thanks for bearing with me.